Hello everyone, welcome to my presentation. My name is Nikila. I am from ECEB and my topic is total probability theorem. Total probability theorem. In mathematics, probability is the likelihood of an event. The probability of an event going to happen in is 1 and for an impossible event is 0. In probability theory, there exists a fundamental rule that relates to the marginal probability and the conditional probability, which is called the formula or the law of total probability. Through several distinct events, if it expresses the total probability of an event. Here we are going to discuss the law of total probability, its statement, proof, doing with its example. Table of contents, law of total probability, statement, proof and example. Law of total probability. For two events A and B associated with a sample space S, the sample space can be divided into a set A intersection B, A intersection B and A intersection A dash intersection B, A dash intersection B dash. This set is said to be mutually disjoint or pairwise disjoint because any pair of sets in it a disjoint elements of this set are better known as a partition of sample space. This can be represented by the Venn diagram as shown below. In cases where the probability of occurrence of one event depends on the occurrence of other events, when use the law of total probability theorem. Here we can observe the total probability theory diagram. Law of total probability statement. Let events C1 and C2 so on Cn form partitions of the sample space S, where all the events have a non-zero probability of occurrence for an event associated with S according to the total probability theorem. P of A is equals to summation. P of A is equals to summation n in k is equals to 0 P of Ck into P of A by Ck. Here we can observe the diagram. Total probability theorem. In probability theorem, the law or formula of total probability is a fundamental rule relating marginal probabilities to conditional probabilities. It expresses the total probability of an outcome which can be realized via several distinct events, hence the name. Formula. P of A is equals to sigma n P of A intersection B suffix n. P is equals to probability, A is equals to any event and B of B suffix n is equals to event. Statement. The law of probability, total probability, is a theorem that states in its discrete case of B suffix n is equals to 1, 2, and 3, so on, is a finite or countably infinite partition of a sample space. In other words, a set of pairwise disjoint events whose union is the entire sample space, and each event B suffix n is measurable then for any event A of the same probability space. Formula. P of A suffix n, P of A intersection B suffix n, or alternatively P of A by B suffix n into P of B suffix n, where for any n for which p of b suffix n is equals to 0. These terms are simply omitted for the summation because p of a by b suffix n is finite. The summation can be interpreted as a weighted average and consequently the marginal probability display style p of a is sometimes called average probability. Overall probability is sometimes used as less formula writings. The law of total probability can also be stated for conditional probabilities. Here we can observe the formula. P of a by c is equals to p of a comma c by p of c is equals to summation n p of a comma b suffix n comma c by p of c is equals to summation n p of a by b suffix n comma c p of b suffix n by c into p of c by p of c p of a by b suffix n into c p of b suffix n by c. Taking the p of n as above and assuming c is an event independent of any of the b suffix n. P of a by c intersection b suffix n into p of b suffix n. Continuous case. The law of total probability extends the case of conditioning one events generated by continuous random variables. Let's be a probability space. Suppose x is a random variable with a distribution function f suffix x and a is an event of, then the law of total probability states p of a intersection minus infinity to infinity p of a by x is equals to x d of x df suffix x into x if x admits a density function f of x f suffix x, then the result is p of a is equals to intersection minus infinity to infinity a into p of a by x is equals to x d of f suffix x into x. Moreover, for this specific case where a is equals to y belongs to b, where b is the Borel set, then the yields p of y belongs to b and intersection minus infinity to infinity p of y belongs to b by x is equals to x f of fx of x into dx. Example: suppose that two factories supply light bulbs to the market. Factory X bulbs work for over 5,000 hours in 99% of cases, where the factory Y bulbs work for over 5,000 hours in 95% of cases. It is known that factory X supplies 60% of the total bulbs available and Y supplies 40% of the total bulbs available. What is the chance that a purchased bulb will work for longer than 5,000 hours? Here we can observe, applying the law of total probability, we have where display style p of a is equals to p of a by b suffix x into p of b suffix x plus p of a by b suffix y into p of b suffix y is equals to 99 by 100 into 6 by 10 plus 95 by 100 into 4 by 10 plus 594 plus 380 by 1000 is equals to 974 by 1000. Here p of b suffix x is equals to 6 by 10 is a probability that the purchased bulb was manufactured by factory X. If b suffix y is equals to 4 by 10 is the probability that purchased bulb is manufactured by factory Y. P of a by b suffix x is equals to 99 by 100 is the probability that a bulb manufactured by X will work for over 5000 hours. P of A by B suffix Y is equals to 95 by 100 is the probability that a bulb manufactured by Y will work for over 5000 hours. Thus, each purchased bulb has 97.4% chance to work for more than 5 hours. Total probability theorem proof. For the above mentioned figure, C1, C2, so on Cn is the partitions of the sample space is such that Ci intersection Ck is equals to pi, where I is not equals to k and I comma k is equals to 1 comma 2 comma so on, and also the events C1 C2 so on Cn have non-zero probability. Sample space S can be given as S is equals to C1 union C2 union so on union Cn. For any event A is equals to A intersection S is equals to A intersection C1 union C2 union so on Cn union is equals to A intersection C1 union A intersection C2 union A intersection Cn so on. Let's consider it as the equation 1. We know that A intersection Ci and A intersection Ck are the subsets of the Ci and Ck. Here Ci and Ck are the distinct for I is not equals to k. Since they are mutually independent events, which implies that A intersection Ci and A intersection Ck are also disjoint for all I is not equals to k. Thus P of A is equals to P of A intersection C1 or union A intersection C2 union so on A intersection Cn is equals to A P of A intersection C1 plus P of A intersection C2 plus P of A intersection Cn. Let consider the equation as equation 2. We know that P of A intersection Ci is equals to P of Ci, P of into P of A by Ci by multiplication rule of probability. Let's consider this as the equation 3. Using equation 2 and equation 3 and equation 1, we can written as P of A is equals to P of C1 into P of A by C1 plus P of C2 into P of A by C2 plus P of C3 into P of A by C3 plus so on P of Cn into P of A by Cn. Hence, the theorem can be stated in form of equation as P of A is equals to summation k is equals to 0 to n P of Ck into P of A by P of by Ck. Total probability theorem example. A person has undertaken a mining job. The probabilities of the completion of a job on time with and without rain are 0.42 and 0.90 respectively. If the probability that it will rain in 0.45, then determine the probability that the mining job will be completed on time. Solution. Let A be the event that mining job will be completed on time and B is the event that it rains. We have P of B is equals to 0.45 and P of no rain is equals to P of B dash is equals to 1 minus P of B and 1 minus 0.45 is equals to 0.55. By multiplication law of probability, P of A by B is equals to 0.42. P of A by B dash is equals to 0.90. Since events A and B dash are the partitions of the sample space S, by total probability theorem we have P of A is equals to P of B into P of A by B plus P of B dash into P of A by B dash is equals to 0.45 into 0.42 plus 0.55 into 0.9 is equals to 0.189 plus 0.495 is equals to 0.684. So, the probability that this job will be completed on time is 0.684. So, a detailed discussion on the concept of the law of total probability theorem downloaded. Law of total probability. Let us start this section by asking a very simple question. In a certain country, there are three provisions called B1, B2, and B3. The country is passionate into the disjoint sets B1, B2, and B3. We are interested in the total forest area in the country. Suppose that we know that the forest area in B1, B2, and B3 are 10 kilometer square, 50 kilometer square, and 150 kilometer square respectively. What is the total forest area? In the answer is 100 kilometers plus 50 kilometers plus 150 kilometers is equals to 300 kilometers square. You are right. That is, you can simply forest areas in each province partition to obtain the forest area in the whole country. This is the idea behind the law of total probability, in which the area of the forest is replaced by probability of an event A. A probability, if you want to find P of A, you can look a partition of S and add the amount of probability of A that falls in each partition. We have already seen the special case where the partition is A and BC. We saw that for any two events A and B, P of A is equals to P of A intersection B plus P of A intersection B suffix C, and using the definition of the conditional probability P of A intersection B and P of A by B, P of B, we can write P of A is equals to P of A by B, P of B plus P of A by BC plus P of BC. We can state a more general variation of formula which applies to a general partition of the sample space S. Law of total probability. If B1, B2, and B3 so on is a partition of the sample space S, then for a event A we have P of A is equals to IP into A intersection BI is equals to P of A by BI into P of PI. Using a Venn diagram, we can see the idea behind the law of total probability in figure. A1 is equals to A intersection B1, A2 is equals to A intersection B2, A3 is equals to A intersection B3. As it can be seen for the figure, A1, A2 and A3 for a partition of the set of A, and thus by the third axiom of probability P of A is equals to P of A1 plus P of A2 plus P of A3. Here we can observe the diagram. Here is a proof of law of total probability using probability axioms proof. Since P1, B2, B3 is a partition of the sample space S, we can write S is equals to UI BI and A is equals to A intersection S, A intersection UI BI, UI A of A intersection BI, and the distributive law. Now note that the sets A intersection BI are disjoint. Since the BI's are disjoint, thus by the third probability axiom, P of A is equals to P of UI into A intersection BI is equals to P of A intersection BI is equals to P of A by BI, P of PI. Thank you.